Bismillahirrahmanirrahim. Inshallah, we will talk today about basic logs and basic log rules and equations. Um, Chapter 4, as you recall, is divided into two parts. The first part of Chapter 4 is about exponential functions. And like this, y equals 2 to the x. And the second part of the chapter is divided into or talks about logarithmic functions. Logarithmic functions and equations. Okay, so this is like y equals log of x, etc. So today we should explore this concepts. And these two exponential functions and logarithmic functions are related, of course, and that's why they are in this chapter. Some of this material we have already covered, and it's going to be a review, and then I'm going to try to elaborate on this, inshallah, a little bit more. Now, today, therefore, I'd like to explain to you what we mean by when we say log of something, and then I'd like to also describe some properties of log or some rules. You can call these log rules if you like, and we should try to solve some log equations. So that's the formidable task actually we have ahead of us. Before we even begin, I just wanted to introduce you to a number, and this number is called E, which is also known as the natural base E. So E is a number like pi is a number. It's one of those famous numbers, and just like pi, it shows up in unexpected places. And the approximate value of E is 2.71, 8281, and etc. So for us, I think it's sufficient if you appreciate E is approximately 2.71 as a value. It's like a number pi, and just like pi, we need to feel reasonably comfortable working with this. It's just a number. It's like square root of 2 is a number. So E is also a number natural base E. That's what it's called. So we'll get back to that in just a second. Then first we're going to try to appreciate what logs are. See, logs help us solve equations like this. Sorry. 2 to what power equals 7? Okay, so this is tricky to solve, and so far we do not have sufficient knowledge to solve this equation, but we'll learn that today. If I told you what 2 to what power is 4, and I think you would reasonably readily understand that x would have to be 2. So 2 squared obviously would give you 4, and x would be 2. Similarly, if I ask you 2 to what power is 8, you would say, okay, that's easy enough too. That's x is equal to 3. But then if I ask you this question, 2 to what power is 7, right? So that's a little tricky, because it's not a nice clean number like over here. See, that's what logarithms help us do. They help us solve equations like these, okay? So what are logs? Logarithms are basically, the way I see it, at least they help us rewrite this equation in different form. So you can write the same equation, 2 to the third power equals 8. You can write the same fact in a different way. It's like saying first name, last name, first name, etc. So you're not changing the facts at all. So you can rewrite this, you see, as log, okay, base 2 of 3 equals 8. Okay, so these two statements are the same. They're saying the same thing. Like, if you can imagine somebody from a different planet, they say log base 2 of 8 equals 8. That makes perfect sense to them. And if they say 2 to this power equals 8, say, what is that? I've never seen that before, right? So it is just that we're so comfortable with this concept that when we see something like this, we're not as familiar. But soon enough, so these two statements mean the same thing. The term log is short for logarithm, and logarithm meaning a process or a guided set of rules, so to speak. Um, so the first thing we have to learn is to speak the language of logs. In other words, we have to be able to change equations like this and convert them like this, and take equations like this and convert them like this. It's like converting English to Arabic, Arabic to English. We should be able to translate these two equivalent statements. So the rule is this. If you have an exponential equation like this is an exponential equation. It's supposed to represent an exponential equation or function. You can rewrite this. Okay, you can rewrite this as follows: log base b of y equals x. Okay, so this is how you change from a exponential equation to a logarithmic equation. Now, what happens here is, if you appreciate, the exponent here is a variable. So the logarithms, in a sense, free up the exponent. They bring it down into normal uh, uh, earthly level, so to speak. So they free up the exponent, so you can solve for x, right? So that's what logs do. They kind of free up the exponents. X is no longer in the exponent area. You see. So that's what logs do. So again, let me do this again. So the way you rewrite this is you say log, okay, base b, and then you go over here to the exponent x equals y, okay? So it's kind of like a circle. Log base b to the exponent x equals y. So log base b, free up the exponent, and that equals y. So it's kind of like a, recycle sign or something like that. Log base b to the exponent x equals y. So let's practice some of this. So when you said 2 to the third equals 8, we can rewrite this as log base is 2, okay, to the exponent, free up the exponent, 3. Now it's free. I am free. I am free at last. So it's like that. So the exponent is free, equals 8. Okay. So log base b to the exponent 3 equals 8. Now the way this is read, the way you read this, so if you have somebody gave this to you, okay, the way you read this is log base 2 of 8 equals 3. Log base 2 of 8 equals 3. That's how you read the statement. Okay, so if you have log base 3 of x equals 5, like that. Log base 3 of x equals 5. That's how you would read these statements. Okay, so let's practice another one. 5 squared is 25. Okay, so let's write this in logarithmic form. Log base is 5 to the exponent of 2, I'm free, equals 25. Log base b to the exponent 2 equals 25. It's kind of like awkward writing, but it's kind of like, oh, no problem, we can handle this. Just put equal sign there, a log sign here, go from here, and then back over here. It's like jumping fences, Okay. On the other hand, we should also be able to go the other way, okay? So if the equation is given to us like this, okay, log base 4 of x minus 3 equals 7. I'm just making this up, okay? So now you should be able to change this to an exponential form, okay? So base is 4 to the exponent of 17 equals this quantity, x minus 3, right? So these two statements are the same, okay? Now that we appreciate that. So the first thing that we learned is how to convert a exponential form into a logarithmic form, okay? That's the first thing that we learned. And back and forth, you should feel reasonably comfortable with this, okay? The second thing I like to suggest to use this. Now watch. 10 to 0. 10 to the power of 0 is what? That's 1. Great. 10 to the power of 1 is 1. 10 to the power of 2 is 100. 10 to the power of 3 is 1000. And 10 to the power of 4, you're getting bored, is 10,000. 1 followed by 4 zeros. Okay? So let's write this again. 10 to the power of 1 is 10. You agree? 10 to the power of 2 is 100. Okay, let's write these in logarithmic forms. Okay? You would say log base 10 to the exponent 1 is 10. And over here you would say log base 10 to the exponent 2 equals 100. Right? So now what I do in my mind is this, okay? I imagine like, write this like along here. Log base 10 of 100 equals, I'm just writing this big so I can illustrate, okay? In my mind, I imagine 10 to what power equals 100? 10 to the second power equals 100, right? So log base 10 of 100 is 2. 10 to what power equals 10? That's 1, okay? In other words, let's do this. Log base 10, okay, of 1, okay? What is this? Well, what I'm trying to say is 10 to what power equals 1? You have to think like that. So you have to imagine in your mind like the little thing you hear. 10 to what power equals 1? Okay, that's how I do it. So, well, 10 to 0 power equals 1. Okay, so log base 10 of 1 is 0. How about this? Log base 10 of 10. 10 to what power equals 10? 1. Log base 10 of 100. 10 to what power is 2. Log base 10 of 1, you're getting it. 10 to what power is 3. Okay, now watch this. Log base 2 of 8. What is this? In other words, if you get 2 to what power will give you 8? If you can, in your mind's eye, if you could say that. Well, this is going to be 3, correct? So log base 2 of 8 is 3. Okay, so how about this one? Log base 3 of 9. 3 to what power, okay, is 2. Okay, now let's do some more of this. Again, what's log base 10 of 1? 10 to what power is 10? 0. How about log base 2 of 1? 2 to what power will give you 1? 0. So how about log base 3 of 1? 0. Log base, I don't know, 2000 of 1? 0. So from here we learn this simple log rule. Log of any base of 1 is 0. The log of 1 is 0. Okay? The log of 1 is 0. Okay? Log of 1 is 0. So log of any base of 1 is 0. Let's learn that. What I'd like to do now is actually introduce you to some log rules. And I'm going to stop there, kind of give you a mental break, and then go on and do some log equations. So there's certain log rules, okay? The first is this. So we learn how to convert a exponential equation into a logarithmic equation. Now here are some rules. Well, now you can be of any base here, so we're going to use base 10. Before I should say, we use base 10 so common is that we sometimes just don't write it. When you see log base 10, you can just say log, and then it's assumed in general to be log base 10. So if somebody says, okay, log of 2, what they're saying is log base 10 of 2. So 10 is such a common base that it is not written. So in fact, it's called the common log. There's another base that's very frequently used, and surprise you what it would be, and that's actually log base e, the number e that I had suggested, 2.71. Okay? So this is also so common that you shorten up, you call it natural log, because it's a natural log. This is called natural base e. Natural base e. So the log of base e is shortened and is written as ln, which stands for natural log. So in your calculator, there will be two keys. Okay? The first key will say log, and that will be assumed that you understood that to be log base 10. And the second key will be ln natural log, and that you would have assumed, the calculator assumes that you know that means log base e. So these are the two common bases that are used. 10 is not written. This is log base e. Common log and natural log. Okay? Now, as just a reminder, log base anything of 1 is 0. Now back to some rules, some basic log rules. So log of a times b, in other words, you have two quantities here, log of a times b, okay, equals log of a plus log of b. For example, if I have log of x times, 2x times y minus 5, for example, I can change this to log of 2x plus log of y minus 5, like that. Okay, that's the first rule. So let me rewrite that. Log of a times b equals log of a plus log of b. Okay? The second rule is this. Log of a over b equals log of a minus log of b. Easy enough. The third rule is log of a to the exponent of b. Then you can bring the exponent to the front, so it becomes b times log of a. Okay. Now let me rewrite these. Repetition is actually brings familiarity to you, inshallah. So you have log of a times b equals log of a plus log of b. And then we have log of a over b equals log of a minus log of b. And the third rule, log of a to the exponent of b equals, you can bring the exponent to the front, b times log of a. And the fourth rule is this. Log of base b, see here all the bases were 10 just to simplify things. Log of base b of a, you can rewrite this as log of a over log of b with any base. Base 10, I chose here, you could do it for any base. So you can separate this out, log of base b of a to log of a over log of b. Okay, so these are 4 basic logarithmic rules, and we're not going to go very far unless we memorize these. So I request you to do what it takes to get these memorized. Write them down, I don't know, 1,000 times, 500 times, or do what it takes at least 5 times, so at least comfortable with these. So memorize these log rules, and inshallah we'll go from there. So as a review, I just want to suggest to you that we define how we convert an exponential equation to a logarithmic equation like this, and back and forth. And then we talked about what the number e was, the natural base 2.71, etc. And then I suggested log base 10 is just a common log, is the 10 is frequently omitted, and log based e is the natural log, the e is frequently omitted. And then we enumerated some basic log rules. Log of a times b equals log of a plus log of b. And then log of a over b was log of a minus log of b. And then we had log of a to the exponent of b, that was b times log of a. And finally, log of base b of a was log of a over log of b. So I appreciate if you work on these and know these concepts thoroughly. Until next time, and we shall continue from it. When I say this, of course, I request you to write these down 5 times if you're comfortable just writing these rules. And next time we'll go from here, learning about solving log equations, inshallah. Until then, assalatu wassalamu alaikum. Alhamdulillah rabbil alameen. Assalamu alaikum.